Let's unpack what are anti-patterns. An anti-pattern is a common mistake that results in negative outcomes. It is the opposite of a best practice. Many best practices are created to help you avoid anti-patterns. Security anti-patterns are common practices that are counterproductive or harmful to an organization's security posture. Anti-patterns will lead to security vulnerabilities. There are many security anti-patterns, but the one that we are going to discuss is from the cybersecurity perspective. You may add more to the list when compared to the legacy on-premise systems. Let's get through various anti-patterns that you might commonly see. First anti-pattern is skipping basic maintenance. In this case, you might see that system and application backups are skipped. There is no disaster recovery exercises and software updates are not performed on solution assets. Such type of anti-pattern leaves system vulnerable to known exploit and attacks. You as a cybersecurity architect will ensure that best practices around system maintenance are enforced at the organizational level, and in some cases, you need to drive it to adoption. Second anti-pattern is securing cloud like on-premises. What is important in this case is to understand that cloud environments offer unique services and configuration that differ from on-premises setups. Failing to properly configure these can leave resources exposed or underprotected. On-premises security controls do not translate well to cloud environments. This can result in security measures that are either too lax or overly restrictive, which hamper performance or leaves gaps. In addition, cloud providers operate on a shared responsibility model. Not understanding this can lead to assumptions that the provider handles certain security aspects that actually fall under the customer's responsibilities. Majority of the time, you will see that on-premises security approaches do not leverage the scalability and automation capabilities of cloud platforms, which results in manual processes that are error-prone and inefficient. You as a cybersecurity architect advise organizations to use tools and services specifically designed for cloud environments. This includes services for identity and access management, encryption, monitoring, and compliance checks. You also drive implementation of a zero trust model, where no entity inside or outside the network is trusted by default. Third anti-pattern is wasting resources on legacy. Legacy systems often require more maintenance and support, which lead to higher maintenance cost. They may also incur additional costs for compatibility and integration with newer technologies. Legacy systems can be slower and less efficient than modern alternatives. They can also limit an organization's ability to innovate and adopt new technologies, which can lead to competitive disadvantages. Legacy systems may not scale effectively to meet the growing demands of the business, which leads to performance bottlenecks and service disruptions. As a cybersecurity architect, you become advisory to initiate modernization and migration effort for the organization to the cloud so that cloud native controls can be effectively used for the workload. If maintaining a legacy system is unavoidable in short term, then you implement enhanced security measures. This includes regular security assessments, patch management, and using security tools that can integrate with older systems. But this is costly affair. Fourth anti-pattern is artisan security, in which focus is on custom manual solution, than automation and off-the-shelf tooling. Custom manual solution often result in inconsistent security measures. Without standardized automation, different systems and applications may have varying levels of protection, which leads to security gaps. Manually crafted security solutions may not scale well as the organization grows. This can lead to inefficiencies and the inability to adequately secure a larger, more complex environment. Developing and maintaining custom security solutions can be more costly than using automated off-the-shelf tools. This includes both initial development costs and ongoing maintenance expenses. As a cybersecurity architect, you use industry standard tools and protocols to ensure consistency across the organization. Frameworks such as NIST, ISO 27001, and CIS controls can provide a structured approach to security. You automate security processes wherever possible to enforce policies consistently. You can use configuration management tools such as Ansible, Shape, or Puppet, and infrastructure as code such as Terraform to automate security configurations and deployments. You should utilize established security tools and platforms that are designed to integrate seamlessly with your environment. Examples include SIEM solutions like Microsoft Sentinel, Splunk, or QRadar, and endpoint protection platforms like CrowdStrike or Microsoft Defender. Fifth anti-pattern is disconnected security approach, in which there are multiple independent security teams and they have their own take and processes. Usually, independent security teams may fail to communicate effectively, that can lead to uncoordinated responses to threats and incidents. This can result in delayed detection and mitigation of security breaches. Different security strategies and policies across teams can create inconsistencies which lead to security gaps. For example, network security might follow one set of policies while identity management follows another, that may leave gaps in overall security posture. Disconnected security approaches can create visibility gaps, which makes it difficult to get a comprehensive view of the organization's security posture. This can hinder the ability to detect and respond to threats in a timely manner. Inconsistent security measures can result in non-compliance with regulatory requirements, which can lead to potential legal and financial repercussions. As a cybersecurity architect, you develop a unified security strategy that integrates all aspects of security, including network, identity, device, application, and data security, and ensure that all the teams works towards common security goals and objectives. Your focus should be on to implement centralized security management to coordinate and oversee all security activities. You can use security operations centers to provide a central point for monitoring, detection, and response. You use a unified threat intelligence platform to gather and share threat data across all security domains. This helps in identifying and responding to threats more quickly and effectively. You also foster collaboration between different security teams through regular communication, joint training sessions, and shared objective. Last one in the list is lack of commitment to life cycle, in which security controls and processes are created at points in time instead of an ongoing life cycle. Security controls and processes that are created as one-time implementation can quickly become outdated, failing to address evolving threats and vulnerabilities. Without continuous updates and improvements, security measures can leave gaps that attacker can exploit. Static security controls can miss emerging threats and new attack vectors. Many regulatory frameworks require ongoing compliance efforts. Treating security as a one-time activity can result in non-compliance, which can lead to legal and financial repercussions. In order to avoid such risk, as a cybersecurity architect, your focus is on to implement security as an ongoing process that includes regular updates, assessments, and improvements. This ensures that security controls remain effective over time. You should review and update security policies and procedures regularly to reflect the latest threats, technologies, and business objectives, and ensure that all stakeholders are aware of and adhere to these updates. You plan to utilize tools designed for lifecycle management, such as configuration management databases and security information and event management systems. These tools will help in tracking and managing the life cycle of security assets and controls. There are several other anti-patterns that you may come across as well. Some additional anti-patterns you can see on the screen. I have noticed that these are the one highly missed in the organization. This happens when security is afterthought process. Each anti-pattern that you see require appropriate security solution and socialization across the application and infrastructure teams. Anti-patterns such as inadequate logging and monitoring reduces the visibility into potential security incidents and delays detection and response. Anti-patterns such as poor key management compromises encryption and other security measures reliant on keys. Anti-patterns such as overprivileged accounts increase the potential damage if an account is compromised. And anti-patterns such as unsecured API endpoints allows attackers to exploit APIs and gain unauthorized access to backend systems. I hope you have now good understanding on the common anti-patterns and probable security solution that can be considered to build secure security architecture.